Section R.2 we're going to talk about on page 12 deals with order of operations. The order of operations is very important. It means if you have multiplication, division, addition, and subtraction, what do you do first and why do you do that? There are set rules that are followed, and you'll see these rules in spreadsheets when you see the little f of x at the top of a spreadsheet and it has a formula in there. Those formulas follow exactly the same rules as these do. So these rules are very, very important. We're going to talk about the rules first, and then we'll go through several applications of them. The first thing that you do is combine numbers inside of grouping symbols. That means that when you have parentheses or any kind of grouping symbols, square brackets, that if you have nested brackets, meaning multiple sets of brackets, then what you do is you work from inside out. The second thing that you do is raise numbers to powers and take any indicated roots like a square root. The third thing that you do is do all multiplication and division in order from left to right. What this means is that multiplication and division, neither one is more important than the other. What is more important is which one comes first as you're reading from the left to the right. So even though it says multiplication and division, if multiplication is on the left, it's more important. If division is on the left, it's more important. Then the fourth step is to do all additions and subtractions in order from left to right. It's the same thing as the multiplication and division. If the addition is on the left, it's more important. If the subtraction is on the left, it's more important. Whatever comes first as you're reading from right to left is the more important. On page 2 of your handout is a saying, and that's called "Please excuse my dear Aunt Sally." What it is a way to help people remember the order of operations. The P stands for please, which means parentheses or grouping symbols. E stands for exponents, or the word excuse. My dear stands for multiplication and division. And again, what you really want to highlight on this is that they are of equal importance. What depends is as you go from left to right, which one is the more important is the one that you see that's on the left. Multiplication and division are of equal importance. And then lastly, addition and subtraction is the Aunt Sally. Again, addition and subtraction are of equal importance. The one that is more important is the one that's on the left. On page 3 you see our first example, and what I've done above each one of the symbols is just write a letter indicating what it is. So between the 2 and the 77 is addition, so there's an A. Between the 77 and the 7 there's a D for division. Between the 7 and the 2 there's an M for multiplication, and between the 2 and the 3 there's an S that stands for subtraction. So on this one we don't have any parentheses, we don't have any exponents, so what's most important is the multiplication and division. So as you see here, our division comes before the multiplication, so that division is more important. So I've taken 77 divided by 7, and a lot of times what I'll do is I'll put a slash through the 77, the divide, and the 7 to indicate that I've used them, and replace that by an 11. Everything else stayed the same. Next thing that I do then is I have addition, multiplication, and subtraction. Multiplication is more important than addition and subtraction, so we do 11 times 2 and get a 22. Now we have 2 plus 22 minus 3. We have addition and we have subtraction. Addition is on the left. It's more important. So we take 2 plus 22 and get 24, and finally 24 minus 3. Our next example, I've done the same thing, writing above what each one of the symbols is. The first one is addition. 25 and 5 is division between those two. Between the 5 and the 2 is multiplication, and then again subtraction. So our first thing that we're going to do as we read from left to right, we run into division. So we're going to take 25 divided by 5 and get a 5. 5 times 2 then, and the next line is 10. So now we have negative 4 plus 10 minus a minus 4. So we have addition and subtraction. We're going to do that addition in the first place and get 6. We have 6 minus a minus 4. A minus minus 4 is a plus 4, so we replace it by a plus 4, and we have 6 plus 4 is equal to 10. On page 4, we have our first example that has some parentheses. And this one actually has nested parentheses. It has a square bracket and it has parentheses inside of it. So if you would, what you could do is you could take your hands and cover up everything except for the parentheses and the 6 and the minus and the 9 and the closed parentheses. That would stand alone, and you could do just that one part of it. If you did just that one part of 6 minus 9, you get minus 3. We leave that inside the parentheses, and now if we take our hand and we cover up the first part, if we cover up the 12 minus 3, we have a square bracket and 7 plus 5, and then a parentheses and a negative 3. So what we have inside the square brackets, we have addition and multiplication. The 5 next to the negative 3, surrounded by the parentheses, indicates multiplication. So multiplication is more important than addition, so we're going to take 5 times negative 3 and get negative 15. Inside the square bracket, we have 7 plus negative 15 gives us negative 8, and I'm going to follow the example down on the left first. So we have 12 minus 3, a square bracket with a negative 8 in it. We have subtraction, we have multiplication. The 3 next to the square bracket without a plus or a minus between the 3 and the square bracket indicates multiplication. So we're going to take a negative 3 times a negative 8. Negative 3 times a negative 8 gives us a positive 24, and we write plus 24, and now we have 12 plus 24 is equal to 36. So on the example that we have on the left there, I changed subtraction into addition. Instead of 12 minus 3, I think of it as 12 plus a negative 3. Over on the right hand side, we did it a little bit differently at that one step. When we took that multiplication, we took 3 times negative 8. 3 times negative 8 is negative 24. So on this example, I did not use the negative sign that was in front of the 3. I had to bring it on down because I did not use it. So again, if you wanted to cross out the 3, the square bracket, and the negative 8, you could do that and replace it with a negative 24. And then you have 12 minus a minus 24, minus a minus 24 is a plus 24, and we get exactly the same answer that we did on the other side. So what I'd really like you to note about these two is it's just a different way of thinking. One, we're thinking of it as negative 3 times a negative 8. The other, we're thinking it as a positive 3 times a negative 8. So when you work a problem, you want to ask yourself, did I use the sign that was with it or did I not? So you might want to start by trying to cross it out so that you know whether you've used it or not. Our next example has a whole bunch of nesting. So on this one, we want to work from inside out. As we read across, we see open parentheses, open parentheses, open parentheses, and then finally a closed parentheses. So working from inside out means going to where we have the parentheses 1 minus 2. We do that and we replace it by a minus 1. Then we back out and we have 3 minus a minus 1, which is really 3 plus 1. And 3 plus 1 gives us a 4. And then finally we have 5 minus 4, close parentheses, 5 minus 4, and inside the parentheses the 4. So what we do then is take 4 times 4 and get 16. 5 minus 16 gives us negative 11. On the next page, what I have is several problems for you to try. The answers are out to the side so you can take a look at them, and then they're worked out entirely for you on the following pages. If you take a look at problem number 2, let me give you a hint how to work that one. What you would want to do is you would want to work the entire top of that problem and get one answer, and then on the bottom of it work it as a separate problem and then combine the two. On page 8, we want to talk about the idea of scientific notation. It's on page 11 of your textbook and page 8 of your lecture notes. Scientific notation for a number is a number of the expression n times 10 to the power of m, where that number in front is a number which can be equal to 1, but it's always going to be less than a 10. What that means is there's one digit to the left of the decimal point. When you convert a number from a number into scientific notation, what you do is count how many places you move the decimal point. If the decimal point moves right, then the number is going to be a small number and a negative exponent. If it moves to the left, it's going to be positive. Here's some examples for you to take a look at and to try the examples that are below.